Hello and welcome back to our channel Quaint Cosmos. Today we are diving into a mind-bending idea from the field of theoretical physics. The idea is a hypothesis, and this hypothesis was proposed by John Wheeler and Richard Feynman. Both are renowned physicists, you know. The idea means the hypothesis is one electron universe. Yes, one electron universe. So what is the meaning of this one electron universe? Means according to them, according to John Wheeler and Richard Feynman, in this universe, the universe we know, there is only one electron. Yes, there is only one electron. Though we know that if you take any atom, so many electrons are there. So countless numbers of electrons are there in the atoms are there in the universe. So therefore, countless number of electrons are there in the universe. You cannot count actually. According to our knowledge about matter, about molecules, about atoms, about electrons, because we know that every atom is having some electron. Anyway, so according to those two physicists, only one electron exists in our universe. And that way, the name of the hypothesis is given as one electron universe. One electron universe. So what is the idea behind this? Means according to John Wheeler, actually what happened, John Wheeler called Richard Feynman late at night, means one day. Okay, the story goes like this. John Wheeler called Richard Feynman late at night with a wild idea. What is the idea? According to John Wheeler, what if there is only one electron in our universe? According to John Wheeler, might be only one electron is looping through the entire universe billions of times, taking countless number of paths. And what we observe as many electrons, actually they are snapshots of the same electron. The electrons we observe in our laboratories, they are actually snapshots of the same electron, same one electron, only one electron. That electron is looping through the entire universe billions of times through time and taking countless number of paths. That means only one electron is there and that electron is zigzagging through time. No doubt this idea is wild. But one more thing is there. We don't know very little about the reality of time, the reality of the universe, the reality of any particle. Whether it is electron, whether it is proton, whether it is neutron, or whether it is any other subatomic particle. We know very little about everything. Concept of time is still not clear. Again, if you study quantum electrodynamics, then you can see that means according to quantum electrodynamics, there is discussion like when electrons move forward in time, means direction of time is in forward direction. Means when electrons move in forward time direction, in that case, what we observe are normal electrons. And when the same electron moves backward in time, then what we see are known as actually positrons. Means antimatters and matters. You know the difference between them, antimatters and matters. Means, you know, positron is considered as the antimatter counterpart of electron. So how these things happen? So according to quantum electrodynamics, when the particles move forward in time, then in that case they are normal particles or normal matter, and when the same particles move backward in time, then in that case those matter becomes antimatter. Similarly, for proton, antiproton is there, for neutron, antineutron is there, and for electron, positron is there. Anyway, we are not talking about here proton and neutron, only electron, because the name of the theory is One Electron Universe. Though this theory is not established, because this theory or this hypothesis cannot produce any testable predictions. You know the prediction is what, but how will you test this prediction? Only one electron exists in our universe. So since this theory does not produce any testable predictions, that's why this remains only as a theory, and this is studied under the subject heading of theoretical physics. So idea of John Wheeler I have discussed. Again, one more question, a related question is there. If matter and antimatter, okay, this thing you know, but why there are less number of positrons as compared to electrons? Because what we observe in our nature, in the universe, number of positrons are less as compared to the number of electrons. Why? That is the question. And to this question, Richard Feynman replied like this: maybe they are hidden in the future. They get absorbed or trapped. So according to Richard Feynman, positrons are hidden. Okay, maybe in the future they get absorbed or trapped. So this was the reply of Richard Feynman. Anyway, originally the idea came into the mind of John Wheeler. He discussed the idea with Richard Feynman, and Richard Feynman readily accepted his idea. Again, this hypothesis fits mathematically with the particles which are used in Feynman diagrams. But anyway, since we know very little about time, very little about the universe, very little about the particles, and since this theory is not testable, that's why this remains only as a theory. But if you like imagination, wild imagination, if you like curiosity, means if you have curiosity to know the reality of the universe, then this theory is suitable for you to study. Anyway, so this was all about today's topic. That's why the title is given that way: one electron and what? Infinite copies. Okay. That means is time. So automatically question arises whether time is playing tricks on us. Okay. Since we know very little about time, negative time direction or future time direction, many things are there. Again, according to some scientists, time is nothing but an illusion. So many unknowns are there in the field of physics or in the field of reality or in the field of science. So nothing can be said about this theory, whether this is correct or wrong. Nothing can be said. Anyway, this opens up new doors in the world of theoretical physics, this theory itself. Okay. So if you are curious, if you like imagination, especially if you like wild imagination, then this theory is for you. You can study this theory in detail. Okay. The main subject under which this is taught, that is known as theoretical physics. Anyway, so this was all about today's topic. If you like this video, please like, share and subscribe to our channel. This is the end of this video. See you in the next one. Okay. Thank you for watching this video.